Geometry, Chapter 8, Section 2, Trigonometric Ratios. Pause, warm it up, come back, check your work. As a decimal, we have 0.67 to the nearest hundredth, right? And 7/24ths, 29 hundredths. Solving for x, we have 7 1/4, 7/5. And solving for x, we have 7 99 hundredths. Today we're going to find the sine, cosine, and tangent of an acute angle. We will use trigonometric ratios to find side lengths in right triangles and to solve real-world problems. So, trigonometric ratio, sine, cosine, and tangent. Trigonometry is trig. Trig is a Greek word for triangle measure. Trigonon, triangle, and metry, measure, to measure triangles. Okay, so let's think about right triangles. By the angle-angle postulate, similarity postulate, we know that a right triangle with a given acute angle is similar to every other right triangle with that same acute angle measure. So triangle ABC is similar to triangle DEF, and they are each similar to XYZ. And we can form these ratios, these equal ratios, these proportions for the corresponding side lengths of these triangles. These are trigonometric ratios. So a trigonometric ratio is a ratio of two sides of a triangle. BC to AC equals EF to DF, which also equals YZ to XZ. So the trigonometric ratios are known as sine, cosine, and tangent. And sine is, the sine of a given angle is the ratio of the length of the leg opposite the angle to the length of the hypotenuse. Opposite over hypotenuse. So sine of A would be A over C. Sine of B, angle B, would be, again, opposite of angle B is length B over hypotenuse C, B over C. We say SOH, S-O-H, opposite over hypotenuse, so. Cosine is of an angle is the ratio of the length of the leg adjacent to the angle to the length of the hypotenuse. So cosine of A would be adjacent B over hypotenuse C, B over C. Cosine of B would be adjacent leg A over hypotenuse C, A over C. We say ka. We say so, sine is opposite over hypotenuse, so ka, cosine is adjacent over hypotenuse, and tangent gives us the other trigonometric ratio, which is TOA, opposite over adjacent. Tangent of an angle is the ratio of the length of the leg opposite the angle to the length of the leg adjacent. The hypotenuse isn't part of this ratio. So tangent of A is opposite A over adjacent B, A over B. Tangent of B is the ratio B over A. So, ka, toa. So the little acronym, so, ka, toa. Sine, opposite over hypotenuse. Cosine, adjacent over hypotenuse. And toa, tangent is the opposite over adjacent. Okay. So, in trigonometry, the letter of the vertex of the angle is often used to represent the measure of that angle. So, the sine of angle A is written as sine A. We're going to write the trigonometric ratio as a fraction and as a decimal, rounded to the nearest hundredth. We're looking for sine of J. Sine. So, So here we have angle J. We're looking for sine opposite over hypotenuse, right? So you simply can set up your ratio. Sine of J is 60 opposite over 61, which rounded to the hundredths is 0.98, almost 1 whole. And that's our reasoning. It's just based on this ratio. So let's find the cosine of J. Cosine ka. J, adjacent over hypotenuse, right? Cosine of J is 11 over 61, and we do the division, rounded to the hundredths, is 18 hundredths. Again, cosine is adjacent over hypotenuse. Write the trigonometric ratio as a fraction of the hundredths for tangent of K. Tangent. So katoa. Tangent is opposite over adjacent, not over hypotenuse, right? So the tangent of K would be 11 over 60. And round out to the hundredths, and you have 18 hundredths. So in a special right triangle, we will write the cosine 30 degrees as a fraction. And again, we can draw the triangle that has, if it's a right triangle, obviously a right angle, and if it has a 30-degree angle, then the third angle would be 60 degrees. So this is our 30, 60, 90. And to find the cosine ka, right, adjacent over hypotenuse. So we can set up that ratio, adjacent over hypotenuse, and simplify, right? So we can see S over S is 1, so we're left with square root of 3 over 2. And we have the cosine of 30-degree angle is square root of 3 over 2. We can use a special right triangle to write the tangent of a 45-degree as a fraction. So once again, you could draw it, or it's drawn for you here. And if we have a 45-degree right triangle, then we have an isosceles triangle, don't we? We have two 45-degree angles. And tangent of the 45-degree, tangent TOA, opposite over adjacent. Interesting. Opposite over adjacent equals 1. So it's kind of a cool ratio in our 45-degree right triangle. Okay, we can use our calculator to find trigonometric ratios, and why don't we do that? So you'll need a calculator, and you can input sine 52 degrees, so just sine 52, and when you do, press enter, you end up with a decimal number, which we can round to the hundredths places. So sine of 52 degrees would be 0.79. Okay, notice that your calculator really needs to be in degree mode, not radian mode. Use your calculator to find the trigonometric ratio for cosine of a 19-degree angle. Cosine would be adjacent over hypotenuse, right? Of a 19-degree angle will be, rounded to the hundredths, 0.95, right? 95 hundredths. Good. Try again, this time tangent. So we're just practicing each of the different ratios. Tangent of a 65-degree angle, rounded to the hundredths, is 2 and 14 hundredths. Okay, the hypotenuse is always the longest side of a right triangle. So the denominator of a sine or cosine ratio, so ka, right? They both have the denominator that is the hypotenuse. It is always greater than the numerator. Therefore, the sine and cosine of an acute angle are always positive numbers less than 1. Some proper kind of fraction, right? Since the tangent of an acute angle is the ratio of the lengths of the legs, not including the hypotenuse, right? It can have any value greater than 0. So let's find the length using our trigonometric ratio. We're going to find the length round to the nearest hundredth. We're going to find the length of BC. We're given a 15 degree angle. And so how can we do this now? Well, from this 15 degree angle, we have the known AC, right, which is opposite. And then we're trying to find this segment which is adjacent to 15 degrees. It's not the hypotenuse. So opposite over adjacent, we're kind of using which ratio? Tangent, right? BC is adjacent to angle B. We're given AC, which is opposite. So we are looking for a tangent ratio. So we can say that the tangent of B is AC over BC, right? And that's just given our trigonometric ratio. And we can say the tangent of 15 degrees is 10.2 over BC, right? And that's just substitution. And we can say then that we can multiply both sides by BC and divide by tangent. Isn't that interesting? So we're using our cross products property to isolate BC, and we therefore can use our calculator now to find BC, or you can use a table. Your book has a table in the very back of these trigonometric ratios, and you could look up the tangent of 15 degrees, and that would be your divisor, right? And we have found in this case that BC is 38 7/100 of a foot. You will be permitted to use your calculator during the testing in this section for sure. So become comfortable with using your trigonometric keys. Do not round until the final step of your answer. Use the values of the trigonometric ratios provided by the calculator. Okay, let's find the length QR, and round it to the hundredths. QR, so again we're looking, we have this known acute angle 63, and QR is opposite that angle, and we know that RP is 12.9. And RP is what kind of side? That's right, it's the hypotenuse. So we're looking at a ratio of opposite over hypotenuse. Think about SOHCAHTOA. Opposite over hypotenuse is our sine ratio, right? So we are going to be able to use that ratio to solve for QR. Okay, so sine of P is opposite over hypotenuse. And now do we have any known values? Yes, we do. We know PR, don't we? And we can find sine of P as well. So sine of 63 is QR over 12.9. That's just substitution. And now once again we're going to isolate QR. This time we simply have to multiply both sides by 12.9, right? There you go. And we can now use your calculator to find sine 63 degrees times 12.9, and then round it to the hundredths. Back and check, and you should have 11 49/100 of a centimeter by simplifying your expression. Go ahead and pause the video, see if you can find FD. Come back and check. Okay, we have a 39-degree angle, and we have a known 20 meters, and we're missing FD, which is the hypotenuse, right? So we know the adjacent, and we're looking for the hypotenuse. Adjacent over hypotenuse. Right? Cosine. We're looking for the cosine ratio here. So cosine of angle F would be FE over FD, right? And that is our trigonometric ratio. So we can say cosine of the 39-degree angle equals 20 over FD by substitution. And how can we isolate FD? Well, we can multiply both sides by FD and then divide by cosine, right? That's our cross products. And go ahead and use your calculator. 25 74/100 of a meter is the length of FD. Good job. Pause, try your lesson quiz, come back and check your work. Sine of 60 cosine of 45, tangent of 84, and cosine of 13 degrees. Good. And round each to the nearest tenth this time. CB again is 6.1, AC 16.2. We have 38 hundredths, 93 hundredths, and 41 hundredths. Good job. Kind of fun. Our trigonometric ratios. So, katoa. Have fun.